Hey class, this video is going to go along with section 11.2a. Says Mrs. Anderson, our objectives today are I can convert angle measures between degrees and radians, and I can draw and calculate angles. So what is a radian? Well, a radian is just another way to measure an angle. We typically see angles that are in degrees, but we can use radians as well. And radians are associated with pi. Pi, like the 3.14, pi radians is equal to 180 degrees. So that's like the conversion between radians and degrees. 1 pi radian is the same thing as 180 degrees. So then pi over 2 radians is 90 degrees because 180 divided by 2 is 90 degrees. 3 pi's divided by 4 is, actually I think it's supposed to be 3 pi over 2. Yeah, 3 pi over 2 radians is 270 degrees. And then the other one that I like to remember is 2 pi radians is 360 degrees. And those ones I like to remember because those are my 4 main angles. Remember, you have 0 degrees, then 90, then 180, and then 270, and then back to 360 around the circle. So 0 degrees, 0 radians, then you have pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi for 360 degrees. So those are the 4 that are good to just memorize. How do you convert between degrees and radians? Since they deal with 180 degrees in pi, you're either multiplying by pi and dividing by 180. If you are going from degrees to radians, so you multiply by pi over 180. If you're going from radians to degrees, you multiply by 180 over pi. So you're either trying to add the pi or get rid of it. So here's a couple examples. 320 degrees, 2 radians. So we want to take 320 degrees and I want to change it into radians. So I will multiply it by pi over 180. And you can put 320 over 1 so you can see that you're multiplying across the top. And you could simplify diagonally. I know I can divide by 10 first and get 32 pi over 18 because both of these are divisible by 10. And then 32 and 18 are both divisible by 2. So 32 is 2 and 16, and 18 is 2 and 9. So we can take out a factor of 2. So we would get 16 pi over 9. And that's as far as I can simplify there. That's the only common factors they have. So 320 degrees is the same thing as 16 pi over 9 radians. If I want to convert from negative 5 pi over 12, I know that the way that I remember it is that I know I want my pi to cancel because in degrees I don't have it in terms of pi. So if I want pi to cancel, I need to put pi in the denominator. That means the 180 goes in the numerator. So then my pi's cancel. And then try to simplify as much as you can. It will make the multiplying easier. So I know that 12 and 18 are both divisible by 6. I know that 12 is the same thing as 6 times 2. And 180 is the same thing as 6 times 30, since 3 times 6 is 18. So I know that I can cancel a factor of 6 in each. So 180 over 12 reduces to 30 over 2. You could reduce that again, or here you can multiply across now. Negative 5 times 30 is, negative 5 times 3 is negative 15, so add a 0. And then on the bottom we have 2, and then negative 150 divided by 2 would be negative 75. To think about that for a second. So negative 75 degrees. Well, we could have simplified 2 and 30 one more time, but that works just like that as well. You could also have multiplied straight across and then divided by 12 in the end. So multiple ways to get to that answer. I think simplifying first is easier, in my opinion, anyway. A little bit of vocab. There's lots of vocab in this unit, so the more we practice it, the better it'll be. We're going to talk about standard position. An angle is in standard position when the vertex is at the origin and the initial side is at the positive x-axis. So that means that your vertex is at 0, 0, and the angle starts at the positive x-axis. So this is the initial side or the starting side. And then it's in standard position as long as it starts here, and if we go to the right or if we go counterclockwise like this would be the ending side is called the terminal side. And this is 90 degrees, so I drew an angle that's approximately 120 degrees. So that's an example of drawing an angle in standard position. So that angle initial side started at the positive x-axis, vertex at the origin, terminal side. So 120 degrees. So we get positive angles when you move from the positive x-axis and you go counterclockwise. You get negative angles when you move from the positive right axis and you go clockwise. For example, if you start with the initial side at the positive x-axis and go clockwise, we won't go all the way, we'll go about there. Let's say I went 30 degrees clockwise, so that would be the negative 30. This angle that it created here would be negative 30 degrees. And then this would be my terminal side. The purple one there would be my terminal side. Now you have the quadrant angles. So this starts at 0 degrees or 0 radians. Then you got your 90 degrees, or that's pi over 2 in radians. The axis over here is 180 degrees, or just pi radians. And then we go down to 270 degrees, or that's 3 pi over 2. It's counting by halves. And then 360 degrees, or 2 pi in radians. So those are those main angles. So if you go all the way up to the positive y-axis, you've gone 90 degrees, etc. So standard position. Next, we're going to talk about coterminal angles. Coterminal angles are angles that are in standard position that have the same terminal side, which means that they start their standard position. So if they have standard position, they start on the positive x-axis, and that they have the same terminal side, which basically means that they start and stop in the same place. So if they start in the same place and end in the same place, that might look like this. Let's say we draw an angle in standard position with initial side, it's positive x-axis, vertex at 0, 0. I'm going to go positive 30 degrees, so counterclockwise. So my terminal side is right here. So I've drawn a 30-degree angle. Now a coterminal angle would be something that starts in the same spot and ends in the same spot. So if I start here at this positive x-axis again, I'm going to go counterclockwise again, positive, but this time I'm going to go all the way around, so that's 360 plus another 30 degrees, and I'm going to end in the same place. So I went 360 degrees plus another 30 degrees, so now I have a total full angle of 390 degrees. 330 degrees and 390 degrees are what we call coterminal angles because they start and stop in the same place. So they're coterminal angles. It works with negative angles as well. For example, if I was to start with the positive x-axis as my initial side again, and this time I'm going to go clockwise and I'm going to go back a negative 60 degrees. So this will be my terminal side. Now say I want a coterminal angle. So I'm going to start at the positive x-axis, and I could go negatively around. So I could go negative 360 degrees plus another negative 60 degrees and be at negative 420. That would be one option. Or I could go start at the positive x-axis and go around counterclockwise and end up here. So that, if I do that, then I have, I went all the way around this side minus 60 degrees. So if I think all the way around is 300 degrees or 360 degrees, minus 60 degrees, I'd have 300 degrees. So 300 degrees, negative 60 degrees, negative 420 degrees are all coterminal angles. They all start and stop in the same place. Those are just a few examples. This picture can be a little intimidating right away, but it just gives you an idea of there's infinitely many coterminal angles. These sides go up by 15 here. So well, it starts with this is 30 degrees here. This is 45 degrees. We got 60 degrees. This is my 90-degree quadrant angle. This one here is 120 degrees. And I have 135, 150, 180, 210, 225, 240. Remember, this one's 270, 300, 315, and 330, and then 360. And remember, 360 and 0 are the most common coterminal angles. So this kind of gives you an idea. For example, this is like an infinite circle. You're going around. Here you're starting at 30, and then 360, then up another 30 would be at 405. Or this would be actually up 30 would be 390, then up 45 would be 45. So 405 and 45 are coterminal angles. 780 and 60 are coterminal angles. 855 and 135 are coterminal angles. 210 and 570 are coterminal angles. And the list goes on. 1,020 degrees and 300 degrees are coterminal angles. It's just with 300 degrees, you haven't went all the way around the circle. With 1,020 degrees, you've went 2 full circles and 300 degrees around more. So those are all examples of angles that start and stop in the same place. These are all coterminal angles. So coterminal angles have specific properties, and we'll get to those properties later on. So that's why we're addressing them now, just the vocab there and what they are. So let's practice drawing an angle with a given measurement and standard position, and then tell which quadrant the terminal side lies in. So remember, the terminal side is the ending side, and our initial side is always the positive x-axis, and then it asks for the quadrant. So let's review our quadrant numbers. If we look at the xy axis, we have the quadrant 1 starts in the positive, x and y are both positive, and then it goes counterclockwise. Counterclockwise. So this is quadrant 2, quadrant 3, and quadrant 4. So if I want to draw an angle that's given in standard position, negative 120, so I have a vertex at 0, 0. I have my initial side is the positive x-axis. So then I'm going to go negative, I got to go clockwise. So this would be negative 90 degrees. This would be negative 180 degrees if I'm going clockwise. And so negative 120 would be negative 90 plus 30 more degrees. So, and the arrow here would show me which direction I'm going. So that would be negative 120, which leaves me in quadrant 3. 400 degrees. Remember, that would have to go all the way around. So 0, 90, 180, 270, 360. So you'd go all the way around the circle one time, and then from 360 to get to 400, you need another 40 degrees. So 400 minus 360 is 40. So I'd have to go another 40 degrees in the clockwise or the counterclockwise direction for a positive angle. So that all the way around in another 40 degrees would be 400 degrees. 2 pi over 9, it is easier if you convert this to degrees, but you could think about it in radians. Remember, this would be 0. 90 degrees is pi over 2. 100 is pi, or 180 is pi. 3 pi over 2 is 270, and 2 pi is 360. 2/9 is the same thing as 0.2 repeating, and then 1/2 is 0.5. So I'm guessing it's going to be in here somewhere in between 0 and pi over 2. So 2/9 is less than a half. But if we converted that 2/9 into degrees, it would be easier for us to draw the angle. So I want to convert to degrees, so I know that I want my pi's to cancel, so I need to multiply by 180 over pi. I'm going to simplify before I multiply across, because I know that 9 is the same thing as 9 times 1, and 180 is the same thing as 9 times 20. So then I can take out a factor of 9 in both of those. And then on the top, I get 2 times 20 left is 40 degrees. And everything on the bottom is simplified to 1. So it is 40 degrees. So starting with my initial side as the positive x-axis and my vertex at 0, I go counterclockwise in the positive direction, 40 degrees. And that would leave me in quadrant 1. The second example, 400 degrees, is also in quadrant 1. I forgot to answer that part of the question. So those are examples of drawing angles in a standard position. So now we're going to practice finding coterminal angles. And I want to find one positive and one negative coterminal angle with the original angle given. So I'm going to start by drawing the original angle, the 100 degrees, in standard position. So I have my vertex is at 0, 0. My initial side is the positive x-axis. Then remember, here's 90 degrees, which means I just need to go 10 degrees further in the counterclockwise direction, so it's positive. And that got a little bit big there, but try that one more time. So initial side, and then I want to just go a little bit over the 100 degrees. So one positive and one negative angle that is coterminal. Think about what it means to start and stop in the same place. Like if you were standing facing me, you're standing here, you're facing me. If you wanted to start and stop in the same place, you would have to turn your body all the way around 360 degrees to get back to facing me. So if you turned yourself all the way around, you start and stop in the same place. Now if you're facing to the left and you wanted to end in the left again, you would go 360 again. So essentially, to get coterminal angles, you're adding or subtracting 360 degrees. Starting in the same place, go around one circle, and then go another 100 degrees, and you will get back to the same terminal side. So if you had 100 plus 360 degrees, that would give me 460 degrees, and that would be one coterminal angle, one positive coterminal angle. Now, if you started in the same place and went backwards instead, you would start and stop in the same place as well. So that would be like if you had negative 360 degrees plus the positive 100 degrees. So negative 360 plus the positive 160, you'd end up with negative 260. The other way of thinking about it is starting with that 100 degrees you had and then subtracting the 360, and you get negative 260. So either way, you're going to get the positive or the negative coterminal angle. So it's all about making a full circle so that you end up back in where you started. If you need a positive angle, you're adding 360 to it. If you need to go negative, you need to take off the 360 to get back to where you're facing, back to where you're at. So 575, first, to even draw this, I know that I need to go around in the positive direction, starting at positive x-axis, one full circle. So 575, take off that full circle. I'm going to be left with 215. So then I need to go another 215 degrees. So that's down here. This number is 180, so it's just past 180. So this is the full circle plus 215 is 575 in standard position. So if I just started with the here and just went 215 degrees, I would start and stop in the same place. So 215 degrees is a coterminal angle. And I can get that angle from subtracting 360 from 575. If I take 570 or the 215 and I go around one more time, I can take off another 360, and that will give me negative 145 degrees, which is also a coterminal angle then. That's if I start to this side and go to the left here, go clockwise down, that's negative 145 degrees. So that is my other coterminal angle that's negative. I'm just subtracting 360. You could also I have a negative 360 degrees, and I'm going to add the positive 215 to it. I'm going to end up with negative 145 either way. So whatever way helps you better visualize it. But if you want to start and stop in the same place, it's all about the 360 degree turn. Okay, I guess that's it for this section. So thanks for watching. If you have questions, certainly let me know.